Assalamu alaikum rahmatullahi wa barakatuhu. So we are discussing chapter number 5, light. Now let's see how the image is formed by a convex mirror. So the image formed by a convex mirror is always virtual and erect uh, for all the positions of the object in front of the mirror. Any position the object is placed, the image is always virtual and erect in case of convex mirror. Now here are two cases when the object is placed at infinity. How is the image? Now consider an object placed at infinity. Infinity means at a very large distance. Now we will take two rays coming parallel to the principal axis. Then after reflection these rays diverge because in convex mirror the rays are diverged and in concave mirror the rays are converged. So concave mirror is called a converging mirror and convex mirror is called a diverging mirror. So here we have considered two rays coming parallel to the principal axis. Now after reflection they diverge, they do not intersect each other. So when produced backwards they appear to meet at point F. So the image formed is virtual and erect. So this is a convex mirror. Here only we consider two rays. They are coming parallel to the principal axis. Now after reflection they diverge. Both diverge. When they are produced backwards, they meet at a point F. So the image formed is erect, virtual and highly diminished. Very small, highly diminished. Now second case is when the object is placed anywhere between infinity and pole. Now let us consider any object AB placed in front of a convex mirror anywhere between infinity and the pole of the mirror. Now we will take two rays coming from the object and falling on the mirror. One ray is coming parallel to the principal axis. After reflection, it appears to be coming from focus of the mirror. Other ray that is falling at the pole after reflection goes along PQ such that angle of incidence equals to angle of reflection. Now this is the convex mirror. The object is placed here between infinity and pole. Anywhere we can place it. So we will consider two rays coming from it. One is falling here and is reflected back, and other is falling at the pole and it is reflected here. So angle of incidence is equal to angle of reflection. When the ray falls at the pole and is reflected back, the angle of incidence is equal to the angle of reflection. When they are produced, both of them are produced. So image is formed here. Now what type of image is formed? Now this image formed is virtual. These two rays actually do not intersect, but they appear to intersect when they are extended behind the mirror. Now what have we concluded here? We have come to know here that a convex mirror always forms a virtual, erect and diminished image. Whatever the position of the object is in front of the mirror, it doesn't matter. The image is always virtual, erect and diminished. As the object is brought closer to the mirror, the image shifts towards the pole and its size increases. The uses of mirrors, concave mirrors, they are used as shaving mirrors because they give an erect and magnified image of the face. Concave mirrors are used by dentists to see an enlarged image of teeth, and these mirrors are used as reflectors in torches, headlights of vehicles such as cars, scooters, buses, trucks and train engines, and such lights to get a strong parallel beam of light. In these equipment, bulb is placed at the focus of the concave mirror. The light rays become parallel after reflection from the mirror. Hence, Here the bulb is placed at the focus, and these are the incident rays, and after reflection they become parallel and form a beam of light. Doctors use concave mirrors to concentrate a parallel beam of light into a small area called focus to examine the small body parts such as eyes, ears, nose, and throat. Concave mirrors are used in solar cookers to collect a large amount of sunlight into a small area that is at the focus, and the vessel containing the food to be cooked is placed in this area. And concave mirrors are used as a reflector in floodlights. In floodlights, the bulb is placed between the pole and the focus of the mirror in order to obtain a diverging beam of light. Now, as we know that concave mirrors are converging mirrors, the light rays are converged at a point after reflection, that is the focus. So, to collect a large amount of sunlight into a small area, these mirrors are used in solar cookers, and also the doctors use these mirrors to concentrate into a small area and to examine the small body parts like eyes, ears, nose, and throat. And they are used as reflectors in floodlights. Here, the bulb is placed between the pole and the focus. Not at the focus but between the pole and the focus to get a diverging beam of light. Convex mirrors are used as a rear view mirror in vehicles like cars, bikes, buses, and trucks to see the traffic behind. As we know, there are rear view mirrors in vehicles like cars, bikes, buses, etc., and they are used to see the traffic coming behind. So, which type of mirrors are used here in rear view mirror? They are convex mirrors. Why? Because we know that convex mirror always produces erect and diminished image of an object. So the field of view is increased. Now what happens? The driver of the vehicle can see the traffic over a large area behind his vehicle. Now big convex mirrors are used as vigilance mirrors in big shops and departmental stores, and the shopkeeper can keep an eye on the customers to look for thieves and shoplifters. Convex mirrors are also used as staircase mirrors in double-decker buses to have a safe view of the dangerous corners while climbing. They are used as reflectors in street lights because they diverge light which is incident on them. So here this is a convex mirror and light rays are falling on it from this bulb and they are diverged over an extended area. We have done about reflection of light. Now let's see what is refraction. As we know that light is a kind of energy and it travels in a straight line as long as it is traveling in the same medium, and whenever it travels from one transparent medium to another, it changes its path or it bends. Now let's go through an activity. Here what is there? We are showing here bending of light in water by using a pencil. So a beaker, water and a pencil are needed for this. And now we take a beaker and fill it 3/4 with water. Now we place a pencil in it. Now what happens? We look at the pencil from above. It appears to be bent. It appears to be bent, raised upwards and shorter in length. So that is all due to refraction of light, because whenever light travels from one medium to another, here light is traveling from air to water, from one transparent medium to another transparent medium. What happens? The light rays bend or they change their path. This is called refraction. So what is refraction? The phenomenon of bending or change in the direction of light when it passes from one transparent medium to another is called refraction of light. Now let's see the speed of light in different media. Now when light travels from one medium to another, what happens? Its speed changes. Now Light travels faster in air than in water or glass. So speed of light in air is 3 into 10 raised to the power 8 meter per second. This is the maximum speed. Speed of light in water is 2.25 into 10 raised to the power 8 meter per second, and in glass is 2 into 10 raised to the power 8 meter per second. So when we compare the speed of light in two different media, what happens? The medium in which the speed of light is more is called optically rarer medium, or simply a rarer medium, and the medium in which the speed of light is less is called optically denser medium, or simply a denser medium. So when speed of light is more, that medium is called optically rarer medium, or simply a rarer medium, and when the speed of light is less, that medium is called optically denser medium, or simply a denser medium.